Hello, Alan.
Hey, Michael. All right, Shree's here too. Hello, Shree.
Hello, everybody. Hey, before the meeting starts, I was curious about one thing, Alan. So, can we replace the Google video meetup link, for the video conference? Can we replace that with an actual invite? Some sort of a repeated Google Calendar invite. Maybe for the rest of the year, it can have, first and third Wednesday.
Yeah, I haven't had time to look into it, but I'm planning on it.
Okay, all right. That it will kind of motivate more of us to join more often. So
Yeah, definitely the next one. I'll have it by then.
okay.
How long would you like to wait?
Let's wait at least until 11:05. That's all right.
Okay.
Seems to be the trend in all the community meetings. Actually, I've attended.
People come late.
Yeah. Sad, but true.
Well, the last meeting ends at 11, and they gotta
Take a break.
take
Yeah.
a quick break.
That's what happened to me. My last meeting just ended at 11, so I needed to join this one.
There should be incentives for showing up on time, like prizes.
I was on time. Where's mine?
Alan, how about you make some origami as prizes? So
Hey, there should be incentives for showing up.
we could have a draw for the origami.
Yeah.
Oh, given the remote nature, maybe you just have to send the instructions, the link to the instructions on how to fold it.
I'll just send a picture.
That works too.
Maybe I could include an NFT or something like that,
Yeah. Oh. Okay.
All right, do you want to start?
Let me see if I can figure that out. My entire screen. Okay, can you see the screen?
Yep.
Okay. So today I'm going to talk a little bit about what's coming up in Iter8, the next version of Iter8, version 0.8. Its major focus is simplification and ease of use, and really we're trying to apply whatever it is we've learned about Iter8 so far. Simplification here means sort of across the board. So conceptually thinking about Iter8, trying to simplify that, simplify the model of an experiment that we have, and continue some things we're already trying to do, which is to simplify the experience for the user through the use of things like templating, and for the developer by merging repositories together. A sort of second part, or another aspect of simplification, I kind of separated it out is what I'm calling zero cost install and upgrade. So this is an approach that is really client tool only. There's no CRD, there's no controller. User wants to run an experiment, they run an experiment, and that's the end of it. And a consequence of this model is an improved security model as well that we'll look at. I have embedded here some links to some references, a GitHub project that contains the work items, not all of them, but some of them related to the project, most of them that have been defined, and a sort of considerations document that we've been working on. So what do we mean by conceptual simplifications? Even at the very basic, what is an experiment? In expressing an experiment as a custom resource in Kubernetes, we're really thinking of it as a desired state. We're expressing the desire to have an experiment be completed, and the controller then makes it so. But really, in the experiment is a list of tasks that gets executed, and some of this is explicit in the form of a list of actions. But some of it's implicit in the behavior of the controller itself to loop through, to interact with the analytics service, to perhaps modify the weight distribution of traffic. These are, in a sense, tasks. And so really we're moving towards, instead of viewing an experiment as a statement of desired state, viewing it as a sequence of tasks that should be executed to complete an experiment. Sort of a second concept that we have, or conceptual mismatch that we have in Iter8 today, is the difference in the way execution is done for progressive experiments. So we have a native implementation that is done by the controller, and it's invisible. You indicate something's progressive, and you provide the necessary object references, and Iter8 will do it. On the other hand, if you want to use an external mechanism like GitOps and create pull requests or commit to a repository, you can't use these sort of native mechanism. You have to actually work around it. So you have to introduce tasks, loop tasks, and you have to disable the native implementation by saying it's not a progressive experiment. And so this is conceptually unpalatable in the next version, we're looking at making the entire interaction in terms of weight redistribution to be the same. So just use tasks for everything. There's another conceptual mismatch that takes place when we use built-in metrics for SLO validation or fixed split experiments. Here in these experiments, really the entire experiment is contained in the start tasks that are defined. But Iter8 by itself requires us to define a loop, indicate how long the loop will run, at least one second of one iteration. Again, this is something that really doesn't make sense, but you have to do because Iter8 requires loops. By turning it into more an observation that it's a sequence of tasks, we eliminate this need for any loops in the experiment definition. I don't say that. You can loop tasks, but you don't need to also indicate that the controller itself should loop. And then lastly, not so much conceptual, but a cognitive difficulty that we have is that, we take a really nice approach. We define all of the variables, version-specific variables in one place as part of the version info. The problem with this is that they're being defined in a place that's quite remote. Metrics defined in separate CRs, and so they're very remote. And the metric itself imposes requirements on the naming of variables and experiments, which are maybe not clear to users. So instead of doing this, we want to change to the definition of variables in the context of their use. So when a metric is defined, if variables are needed, we need to define the variables there. If they're needed for a task, then we should define the variables there. And so that's the idea. If people have questions, I actually cannot see anybody right now, so please just speak up and ask your question. Otherwise, I'm just going to sort of keep going.
Michael, one question on the last page. Under user traffic weight redistribution, are the bullet regarding GitOps, are you saying there's a new loop task that shift the traffic now?
Not a new one. This is sort of a statement about what will we do. So today you define a sequence of, if you want to do progressive rollout with GitOps, then you would define in the actions, you would indicate you have a loop action, and the loop action would be to create a pull request or create a commit against a repository with the new weights on the virtual service or whatever the mechanism is. That this is how you would do it today. Mm-hmm. In the new version, I'm not changing that, same behavior. The difference is that if you wanted to use the quote native Istio iterate approach, instead of defining the we'll introduce a new task, which is really a iterate redistribute weight, which takes as parameters the objects that it should manipulate, and then it will do it as it does today. But the point is, the expression of the redistribution is explicit, and it's in the same place it would be for GitOps. So it becomes a replacement as opposed to two completely different methods of expression.
The reason we want to implement the more GitOpsy implementation versus the controller kind of in cluster implementation is because some applications are more long running, like I guess ML training, all those things would take days. So we would want to kind of commit the traffic shifting into the repo as opposed to kind of making the changes directly.
Yeah, it's not so much about long running versus not long running. It's more a statement of, well, what is the mechanism that I as a user of Iter8 have for making changes to the configuration of the traffic in my cluster. If if I'm okay with Iter8 as a system automatically going ahead and making those changes, that's fine. Then you would use an in-cluster implementation. If my approach is more of a GitOps approach, this says if you want to change traffic, if I'm going to change traffic in my cluster, I'm going to modify the resource in GitOps and have the Argo CD implement that change, then that's how I want it done. And Iter8 should support that capability as well. And this is kind of what's behind the existing examples that we've done with GitOps. Is in order to do them, we've written tasks to create the pull requests.
Okay, thank you.
So is it fair to say, Michael, that this is a statement of capabilities and not really a statement of what we are recommending users to do? Because users will, based on their organizational requirements, they will have their own preferences in terms of how they want to quote unquote implement Iter8. So this just lets them do whatever they want to do.
Correct, and Iter8 does that today. That doesn't change. What changes is only the way in which the two variations are expressed. Instead of having two ways to express it, we're trying to unify it into a single way of expression, or a common way of expression. Of course, the specific task that gets used is different. Sorry, I'm taking a note because that's a better way to say it than what I wrote here. In terms of model simplifications, really I have here a whole litany of changes, and I'm going to express these changes in terms of the existing model CRD that we're familiar with. And I'll go over them very briefly. I'm just going to justify some of them, but my intent isn't to really dig into the details. So today we have a strategy that captures a testing pattern, a deployment pattern, some weights and actions. Really, the goal is to eliminate all of these but the actions and sort of pull actions up a level. Testing pattern is something that can be computed. Deployment pattern is something that's just confusing and is really about user intent, and the sequence of tasks describes that. And weights we've never used. Today in our we have a distinction between start, loop, and failure actions. If we think of an experiment as just a sequence of actions, we no longer need this distinction. It's just a sequence of actions. The duration today, we have two concepts for duration. We have a concept of an iteration and a concept of a loop. We started with the idea that we should unify these. But again, if we're going to have a notion of just a sequence of tasks, then there will be a need to express a loop or a sequence of tasks that is looped, and in that loop we would define really the duration of that loop, not of the experiment as a whole, but really focus on the loop. We have some variables like rollback on failure, which we're not using. We're going to eliminate that. I didn't mention it here, but at least for now, we're going to remove the indicators because, again, we can bring them back at any time, and really, we don't have any use cases where we're in fact using them. We want to refactor, as I mentioned, version info. So remove all of the variable definitions from there. And as a result, the version info really becomes just a simple list of version labels. And we use this list of version labels to allow the user to understand which version we refer to, and as an index to other things. As I said, remove the metrics CRD, incorporate really into the experiment. There are a number of fields that we want to eliminate. The notion of a target. This is something that really is being used for only for concurrency control. We believe that concurrency control better belongs outside of Iter8 in the form of a pipeline, either GitOps or something else. And so we're going to remove it for now, and the associated variables that go with it. And refactor analysis, status.analysis is horribly complicated. We just want to simplify it. and remove version recommended for promotion, which seems confusing to users. And just simplify, we have a winner or we don't have a winner. So that was a sort of a litany. Any of these raise questions in anyone's mind?
It makes a lot of sense to eliminate these. This is a really good thing. Can I ask, I guess I have two questions. The first question is, what does it mean by remove the metric CRD? So what do we use instead?
So I shouldn't say remove, I should say replace. We're going to move it as a CRD. We're going to incorporate a metrics definition into the experiment itself. Let me actually show you an example.
Makes sense, Michael. Before you get to the example, can I ask one more question?
Sure.
This is a more general question. I guess when you change the CRD definition, are we breaking backward compatibility?
Absolutely, we are.
Okay, so we made a decision, like even without making a major version change, we are allowed to break the backward compatibility.
So in thinking about this from the perspective of a CRD, this is a version change in the CRD. So we move from one alpha version to we're actually thinking to go to a beta version. Because we're at alpha level, breaking compatibility is an acceptable strategy. However, as we let's sort of hold that question a bit, because as we think about a zero install mechanism, sort of CRD-less and controller-less mechanism, we actually are able to run experiments with multiple versions simultaneously without any problem. So it really goes away as an issue.
Okay, thank you.
Oh, one other thing. I think we will. It's not directly related to your question, Hai, but I think we are going to have to support 0.7 and 0.8 for a while because of practical migration issues. There are many integrations already, and there is documentation already going out. So until we have a clean migration of all those things, probably 0.7 is here to stay for some time. It won't just disappear suddenly.
Yeah. So, example. So this is an example I pulled up from really one of our test cases for Iter8 CTL. Is it legible or do I need to make it bigger? I feel like it needs to be bigger. I don't know how to make it bigger. There we go. That's bigger. So as I said, versions, just a list of versions. So I actually picked a more complicated example. I picked an A/B test with really progressive rollout as an example, just to show the simplicity. So it's 2 versions. There's a list of objectives. There's a reward. The expression is very similar. The duration is simplified. Again, this will go away. I don't have any actions in here. I should have put actions. I'm sorry. The metrics definitions, the criteria are expressed very simply. They're referring to a metric. The metric is expressed here down below. And the idea was to sort of consolidate in the metrics definition. There are a number of fields that are the same. The method to query Prometheus is the same. The provider is the same, Prometheus. The JQ expression is the same. The URL to Prometheus is the same. The set of variable definitions used in all the queries is the same. So really to capture this in what we call a backend for an Istio, set of Istio metrics, and then to explicitly define each of those metrics. This is a very similar definition to what we had in Iter8 0.7. It's just shortened because we've pulled out the common pieces. So this allows us, this mechanism allows us to define sort of multiple references. We can be using Istio, Prometheus as a backend. We can be using New Relic as a backend. Both together with metrics defined for each, defined differently, and the metrics are being defined directly where they're being used.
Just the wording backend seems to be very generic.
Yes.
Is it possible to make it like more explicit, like metrics backend, or just metrics a little bit more understandable when looking at it.
Yeah, good idea. This experiment, I believe, all good. It shows us the status as well. So here we see an example of how we're simplifying our analysis. If you recall what our analysis looked like, it was much more complicated. For each major field, we had a where did it come from, who made the recommendation, when was it done kind of statement. We eliminated all of those things. The order is the order of versions defined in the definition. We don't explicitly state the version. It's just we expect it's by order. And not visible in this example, these lists of metrics, these metrics will become lists of metrics. So we actually will maintain a history of the values that were observed.
So I have a comment on the conditions. I think the actual content of the conditions makes sense to me, but we may not want to do it as conditions field in the status simply because there is I think there is a notion of desired state getting reconciled and different conditions observed during that process. That notion is kind of tightly baked in with this conditions concept, I think, with Kubernetes APIs. So
yes.
Obviously we want this information. It's useful information. So succinctly summarizes where the experiment is at, what happened. We want it, but maybe we don't want to call it conditions. We will redistribute that information throughout the status, however appropriate.
Yes, this is probably true. It can be simplified. So again, as we think about a controllerless, CRD-less mechanism, I think you're right. Conditions is something that we can change. I think stage becomes something that we change. Stage today captures sort of where are we? Have we done the start? Have we done the start actions? Are we iterating? Are we running finish actions? That's kind of the information that's provided. And perhaps it changes now to explicitly tell us which task we're running, which tasks have already completed, that kind of thing. So we have a sense of where we are in the progress, as opposed to this more general sense that doesn't make sense anymore. So yes, there are changes still that need to be made as we move to a controllerless mechanism. Okay. Any more questions? I copied it. Any more questions about the model changes, or the set that we're working with at this point? Again, this is all work in progress, so suggestions and thoughts on further simplification are most welcome. In terms of I skipped something. I got them in the wrong order. Developer simplification. We've already done this in 0.7. It was actually inspired and thought of as a 0.8 or 0.9 issue, but we decided to do it earlier, really to merge three very closely related repositories, etc3, Iter8, CTL, and Handler. We're finding as developers, we're constantly going back and forth, updating them as changes are made in one or the other. And as we go to the future, whether it's in version 0.8 or later, is to also merge this into Iter8, the Iter8 repository as well, creating essentially a mono repo.
Hey, I have a comment on that. I think there is actually a way to go even further, which is you need one repo minimum. That's not what I mean. So we have two different CLIs today. There is the Iter8 CTL, and then there is the handler. So I think there is a possibility for us to just make it an Iter8 CLI. And it can be Iter8 run. So you just run the experiment, and then Iter8 debug, Iter8 describe, Iter8 assert. So we can just have a single CLI, I think, even going, because you already put it all together in a single Go package. So it's just a matter of now that the command execution that we are using needs to have a single point entry point. So I think that's actually doable, fairly easily doable.
Yes, probably. Certainly, as we go to controller list, what's currently in the controller part of this, the etc3 part, or what used to be, would go away, or be merged into the handlers and the Iter8 CTL.
Yep.
Yeah, absolutely. Sort of user simplifications. So we'll see an example. We've already started sort of advocating use of templating for experiments. As we move to controller lists, so maybe let's just make a statement. What does it mean when we say CRD list and controller list? It means that we're going to need to express our experiment not in an experiment CR, but rather maybe in another object like a config map. And so in the same way that we create an experiment, we apply a YAML, we would do the same to create a config map, and the config map would contain basically the YAML of an experiment. In addition to this, there are other things that need to be created. An experiment, in order to run, the tasks may need access to things. They need RBAC rules to be applied. Of course, the user can apply these separately, but they could be included as part of the experiment. So they're part of an experiment, making sure they've been defined. Rather than make it a separate step, they could be incorporated into the template. When we create the experiment, we create not just the config map, but the necessary roles, the necessary role bindings, and so on. And what does it mean to run controllers? Well, today when we run a sequence of tasks, we use a Kubernetes job to do this. And presumably, the obvious thing to do here is, again, a managing job to run the sequence of tasks that are defined in an experiment. Again, we could incorporate this job into a Helm template and the entire thing be deployed at once and started at once. As we begin to, and this is a maybe, because we could also create the job using Iter8 CTL, for example. But the point is that as we increase the number of objects that we're thinking about, templating really becomes a much more attractive option, because it's not just one object we're creating, it's multiple objects that may need to be created. Okay, let's go on and talk a little bit about this idea of zero cost install, and I kind of hinted at that. Today, using Iter8 requires the installation of a CRD, it requires the installation of a controller, and both of these tasks require the cluster admin access to do this. And any upgrades require cluster admin access. Each time we upgrade our handler, our task runner, we need this access. Anytime we create new tasks that have additional permissions required, it requires cluster admin access to install the RBAC rules. So these are challenges that stand in the way of use of Iter8. And so the thought is, well, why do we need to install anything at all? Let's go ahead and just run the sequence of tasks using our task runner in the local namespace where the experiment is defined. Define the experiment as a config map, run it with a Kubernetes job in the same namespace. The ability to define any RBAC rules needed is something the user can do themselves. And we can manage this whole thing with Iter8, which is a client-side utility. And so it becomes something that any user with permission to run a job in his namespace and create a config map, which are minimal requirements, should be able then to run Iter8. This has the benefit, as I said earlier, that given a combination of job and config map, we could be running two jobs on two different experiments using different models. As we upgrade, there's no need to reinstall a controller. There's no need to restart jobs that are in progress. They can just continue. They could be using different versions of the task runner. If we've upgraded the version, there's no issue there. They just, whatever's running continues to run, and we can run new ones.
So Michael, I think the last time we talked about this, another possibility was instead of using config maps, was actually using metadata within the deployment itself. I'm wondering if that's still on the table, or we think that config map is the way to go because of the complexity of the content of the CR that we need to put in there.
Yeah, I'm inclined to feel the latter, that it's still complex. So what I was sharing about model changes, I showed it in the context still of a CR. When we change it from a CR to a config map, most of that content is still there. And so I think from an expression perspective, it's hard to stick that into objects.
I see. Okay, that's fair.
I suppose in principle, it could be attached completely as an annotation. You know, stringify it and attach it as an annotation, similar to what you see as the last configuration in objects.
Right, I see some, I don't remember which, but some tools can use fairly complicated annotations like what you said, right? It's basically stringify it. It looks kind of ugly, but all the content that you would need is self-contained within the annotation. It does have the benefit of, everything's self-contained within the single deployment spec, instead of having a separate config map. But yeah.
So I think it's, we might want to think a little bit more about this. I mean, I think that we will want to have a mechanism really to inject it if we're going to do that, so that user expression of their application and the ability to run an experiment on an application are not necessarily tied together in the definition of the experiment. If we do that, how are we expressing it? I mean, in essence, when we put it in a config map, all we're really doing is, we're stringifying a YAML file and sticking it in the config map.
Yeah.
So it's a very similar expression. I think it may come down to permissions. It may come down to what makes sense, what's easier, how do we express it.
Also, the job is going to update the status. So it's continuously running, and it's going to continuously update the status. So
good point. That will be an issue for GitOps.
Yeah, potentially.
So if we're using GitOps to manage our application, and we're constantly updating the annotations in them, that may become an issue. I don't know. I don't know whether they pay attention to annotations, so I assume they do. Well,
okay.
They must ignore some. They must ignore last configuration. So I don't know.
If it's kept in the config map, you don't need to update it for GitOps?
So I have a slide about GitOps in a minute. Let's get there. So here are some conceptual examples. I haven't tried to express a whole experiment, but more just to express the kinds of list of tasks that would be needed. So today's SLO validations just become a list of 2 tasks, the readiness and the collect, the metrics collect. Maybe a blue-green rollout using GitOps would be again the readiness and the collect, and then some kind of get a recommendation from the analytics, and maybe that's done in collect. I don't remember. And then it creates some kind of pull request. If the green version 1, create a pull request to apply the green version. And then this is an example maybe of a progressive rollout. And again, keep in mind these are conceptual. They're not thought through, and they certainly don't work today. Again, a readiness check, and then a loop which contains within it a sequence of actions and some control functions over the loop. Again, the behavior when it finishes. So today we would call the first one the start action, this loop would be the loop actions, and these last 4 statements would be the finish actions. We don't need those labels, we just sequence the actions together. I have sort of added a at version to our task names. I don't talk about this explicitly, but the idea here is we need to begin thinking about what it means to version our tasks. Today we've already upgraded our collect task to behave a little bit differently, and no doubt we will others as well. So let's sort of talk through some of the considerations we need to consider here. How do we run the experiments? So I've talked about version 7, we know that. For version 8, what we're thinking about is, we're going to create a config map with some RBAC rules and a job. Or we could just do the config map and the RBAC rules, and we could start the experiment maybe explicitly using an iterate execute command of some kind that would refer to the existing config map. Or maybe it refers to a file that contains these things in it that it would apply first. I don't know. If we think about annotations, as was suggested, maybe this execute command would inject the annotations into the object and we would need to refer to them. So that might be another approach. So these are just thoughts. They're open for discussion, and there is, as I said, a reference document we can look at, make comments in, and sort of figure out what it is we want, and we'll create the issues and begin to do this. We need a mechanism to watch experiments, to monitor their progress. Today we can do this with sort of a watch on kube control get. We would need to move this more to an iterate control get of some kind. Watch the experiment, maybe we need a watch as well. It would return maybe the same kind of information that get returns today. Because tasks become a key concept, we would also want a way to see which tasks have run, where did the failure happen maybe. Or maybe this is part of the debug command, that there's maybe a tasks option on debug which will list the tasks and the progress through them. Maybe that's part of get, I don't know. There are certain functions in the controller today that are being implemented by the controller. There's semantic validation of the experiment. There are status updates. Today it's stage, but as we move forward, it would be maybe what tasks have completed. And there is the management of the loops themselves. So initially, we might think about implementing these as tasks that we can explicitly add to experiments. But over time, these could be, instead of adding them explicitly, it could be done implicitly, or in fact become part of the behavior of the task runner itself. And this last option is really maybe our end goal, because the user, when we show a list of tasks, wants to see their tasks. They don't want to see maybe additional tasks that are inserted into the path. So GitOps, the relationship to GitOps. So we took a fair bit of care in 0.7 to avoid updating our experiment spec so that we could deploy experiments using GitOps. You would write the experiment to a repository and our GoCD would create the experiment in the cluster. And we avoided writing to the spec. The status got ignored by the GitOps tool. But the truth is that in concept, tasks themselves could write to the spec, which would cause a problem for GitOps. At present, we don't have any like that, but in concept, we could. And so really, as we move to version 0.8, we're beginning to think, well, maybe the GitOps is there to support the deployment of the application, but maybe it's not there to deploy experiments, that maybe experiments are deployed outside of the GitOps system. you sort of advocate that as a mechanism. So it doesn't manage the experiments, just the application. And the user uses the Iter8 CTL to start experiments. And as a result, the objects that we're creating are ignored by GitOps. So that's kind of our thinking about this. If we try to watch config maps and we're constantly updating them, we're going to have a problem.
So quick comment, Michael. I think we actually do support creation of experiments by GitOps, even in 0.8. I don't see anything that you've shown so far that is going to get in the way of GitOps experiments. I think what you're saying is we don't do continuous resync of the experiment artifacts through GitOps.
Yes.
So you just turn off the sync for the experiment. But certainly, I think it makes sense to even create the experiment GitOpsy way. You just, whenever you are launching a new version of the app, you launch an experiment alongside that new version, and the experiment does its thing. I think that kind of makes sense, even in a GitOps setting. That kind of a GitOps interaction is possible, and for some organizations may be desirable. So I think it's definitely possible. I just wouldn't do a total, resync of the experiment artifact in a GitOps way. That's the only part that I would turn off.
So is that easy to express, that you don't want these objects to be?
In Argo CD, yes. In Argo CD, you can just simply turn off sync. I haven't yet studied Flux carefully, but in Argo CD, you can simply say, I don't want certain objects to be synced. If it goes out of sync, it goes out of sync. I don't even care. So you create it once, and you
so yes, that would be another example. And you're right. This create a version and an experiment simultaneously is something that makes sense.
Of course, that's not to say you cannot use a CLI to do it. You certainly can, but it's also possible to. I mean, we are also thinking of Helm templates for the experiment. You can just give the Helm values, Helm chart and the Helm values to the GitOps system. That will do the deployment also for you.
Mm-hmm. Okay, so I hinted that we get an improved security model out of this. And this is something that we get because of where we're running our task runner. So in version 0.7, we're running our controller and our task runner in the Iter8 system namespace. And the task runner in particular both need access to objects in multiple namespaces owned by different users. And this creates a potential security issue. That a task runner may run something that accesses something in a different namespace. By running tasks explicitly in the namespace or jobs in the namespace where the config map is defined, where the experiment is defined, we're really limiting the scope for permissions. And these are permissions that are being granted explicitly by the user or through the Helm chart. But again, their scope is limited to the namespace. This is, of course, something that can be done even in our existing model. We could move the execution of the task runner in particular down to the namespace. We haven't done that yet, but we get that really here for free. I think that's the last slide I have. Are there any questions? Anything that perhaps we need to look at and consider that isn't been listed so far that we can think of?
We kind of discussed this earlier, but I think it'll be nice if we take a crack at we have a few basic experiments based on built-in metrics. I think we can try taking a crack at how those experiments look like in 0.8. And yes. I don't just mean the experiments. This is, again, idea is to flesh out the top-level concepts first before we dive into the lowest level details. So that's the motivation here. So I don't just mean the experiment itself. Maybe we can even take a crack at the 0.8 tutorials for those experiments, and then see, is this the simplest way to describe the experiment? Is this the simplest way to install the experiment? And
Yes.
and then we can, we can certainly reverse engineer. I mean, if this is the shape of the description we want, this is the shape of the experiment, dynamics we want during the install and during the debug, during the describe, if this is what we want to get out of it, then what should the underlying mechanisms be? How can we actually, implement the handler or whatever to achieve those mechanisms? So I think,
Yes.
yeah, that may be the approach to,
Yes.
level of detail approach.
Yeah. So I have actually I started to do that for actually an Istio one because I was interested in what it would look like. And that's one that it should be very similar, like a simple single version SLO validation. It should be similar to the others that we've already done using Helm. So I started to do this. And I even, just for myself, modified my Iter8 CTL to run an experiment using an existing experiment definition. So I can create a version beta 1 experiment and run a job that runs the task runner that executes the experiment. Just as a way of being able to see a little bit the behavior with some of the model ideas that we have in mind. I do have some thoughts. I'm not sure that, to be honest, I feel like maybe there's some changes we need to make in our metrics, especially for built-ins. But let's talk about those as we develop these tutorials, as you say. That's a good example. All right, Alan, any last comments for our
No, this
meeting?
is a very good summary of the changes. I was wondering if you could possibly share the slide deck and I can upload it and also have it with the video.
So there is a link to the slide deck in the announcement that I put in the general channel.
Oh, okay. Okay.
Yeah.
Okay, cool. Yeah. All right. Well,
Our next community meeting is in 2 weeks, correct?
yes. Let me just check. This is I believe it will be on the 20th. Okay, cool. All right. Well, thank you for coming. And also this call.
Thank you, everyone.
Is going to end in 7 minutes anyway. So see you guys in 2 weeks then.
Yep. See you. Bye.
See you.